So it is my great honor to introduce a man who needs no introduction. I'm not sure where he's at, but I'm sure he's going to come in here somewhere. Where is he? Oh, okay, there you go. A gentleman who we can call Elon, and everybody, at least in this country, will know exactly who you're talking about, but Mr. Elon Musk. He's the CEO, lead designer of SpaceX. Everyone, I think, knows this. SpaceX is an amazing commercial company. It's the first company to launch a commercial rocket into low Earth orbit with their Falcon 1 launch. Then in 2008, they were one of the winners of a contract to bring services to the International Space Station. They're the first commercial company to berth with the International Space Station, bringing supplies. They're also the first commercial company to return a sizable return vehicle with all the components still intact, which is very important to us, back to the surface of the Earth. And so it's an amazing company that's done a great job and continues to push the boundaries. You'll hear from Elon, but his interest really is not so much in low Earth orbit as it is going beyond low Earth orbit and making sure humanity will continue to live by exploring beyond Earth. Elon has a varied history of things that he's been involved in. This is one of the things that makes it so exciting to have this conversation with him today. You know, he's not one-dimensional space guy. He's involved in Tesla Motors, which he is a co-founder and CEO, and also a major player in the design efforts and what they choose to go build and how. Of course, he was a co-founder of PayPal and Zip2. He's deeply involved in a number of other industries as well. And so it's my great honor to welcome Elon Musk to the stage. Thanks for coming, appreciate it. Okay, well, these are great chairs. You guys, look at those chairs you're in. Let's see, so Elon, you and I were going to have a little chat this morning. We said it was going to be a fireside chat, so minus the fireside, I guess we're ready. Again, as you heard, I've encouraged folks to ask a few questions along the way, but I have a few questions I thought to get us started. So the first one, which is probably on everybody's mind, is perhaps you want to discuss a little bit about the recent loss of the Dragon and the Falcon 9 here on SpaceX 7.
Sure. Well, I mean, I think it's obviously a huge blow to SpaceX, and we take these missions incredibly seriously. Everyone that can engage in the investigation at SpaceX is very, very focused on that. And in this case, the data does seem to be quite difficult to interpret. Like, whatever happened is clearly not a sort of simple, straightforward thing. So we want to spend as much time as possible just reviewing the data, obviously going over it with NASA and with the FAA and with a number of other customers, and just sort of seeing what feedback everyone has based on their prior experience, to see if we can get to what the most likely root cause is. Look at both what we think most likely happened, and then anything that's a close call, and try to address all of those things and maximize the probability of success for future missions.
Any hints on where you think the problem lies?
Well, I know there's media in the audience, so they'll...
Yeah, so you have to be careful. You're right. I never really learned that, but clearly that is a lesson I'm working on.
So it's, yeah, I mean, I think we'll be able to say something more definitive towards the end of the week. At this point, really, the only thing that's really clear is that there was some kind of overpressure event in the upper stage liquid oxygen tank. But the exact cause and the sequence of events, there's still no clear theory that fits with all the data. So we have to determine if some of the data is a measurement error of some kind, or whether there is actually a theory that matches the sort of what appear to be conflicting data points.
Okay, very good. I'll just make a comment. The tweets you put out regularly, particularly when events like this happen, are really useful to everybody. We really do appreciate it. You'd be amazed at how many folks quote what you said, and how glad they are that you just step right out and at least give some sign about what's going on, and that we'll get through it. Things are going well, so we appreciate that.
Absolutely, and for sure, as soon as we think we've got a clear line on what happened, and we've sort of cross-checked it with as many experts as we can, and we certainly appreciate the feedback from NASA on this front. Very much appreciated. We'll certainly put out that story. My only reticence about saying something quite yet is I don't want to say something that subsequently turns out to be a misunderstanding of the situation.
Oh yeah, absolutely. Understand that. So one of the questions that I ask myself regularly is, at what point does all this government help hurt? So this event occurred, and we have you have NASA folks there from about 3 different programs that intend to use your services, ISS being one of them. You have the FAA that's involved. The range folks are there. Without feeling like you're giving your customers a hard time, how is that interaction, and what should we consider doing differently so that we, in those areas where we can help, we are helpful, and in those areas where we're really keeping you from getting your job done, we can modify ourselves?
Yeah, actually, I think the interaction with NASA has been great thus far. The biggest challenge is there are a lot of inquiries coming in simultaneously. So it's hard to sort of keep, respond to everyone right away. But actually, it seems to have gone fairly well. The biggest thing that's needed in the sort of short term is the ability to sort of gather all the data, create a very precise timeline, so that by the millisecond we know what each sensor was reading, and we can correlate that with ground video. And actually, like, one of the biggest challenges is matching the things to the exact time. Because when you're talking about a matter of milliseconds, being able to say what is the ground track video compared to the data as received by the by the ground station from the rocket, and then taking into account for the actual time taken to generate a packet of information. When was that sensor read? When was it encoded into a packet? And when was that packet sent to the ground? When you're dealing in milliseconds, all that stuff actually makes quite a big difference.
Yeah, sure.
So that's the biggest sort of effort we've been engaged in thus far, is just putting together a super detailed timeline, and then just making sure that we have the sequence of events down as precisely as possible. That's what we've been working on. And but actually, certainly with the interaction we've had with NASA and with us, it's actually been quite good thus far. And we've explained that this is what we're doing, and then we very much welcome any feedback or input or review of the data that would lead us to a better understanding of the circumstances.
I thought we had a very productive discussion back when we had the Engine 1 anomaly, and so I found it to be very useful. But that's a perspective from a NASA perspective, so it's always interesting to know your perspective of that.
Yeah, it seems to be quite good actually right now. Yeah.
So you're building, in the last couple launches you've had landing legs, and you've been working on landing the first stage back eventually to shore. Can you talk a little bit about that and what your vision is for that and for SpaceX in general as you go forward?
Sure. Well, the overarching goal of SpaceX is to try to advance the state of space transport, advanced space transport technology to the point where, get as far along the path as we can to where space travel is hopefully commonplace at some point in the future. And and where we can send large numbers of people and cargo to other planets. And it's like that's the sort of thing that needs to happen for humanity to have a great future in space. So we want to keep pushing that. And I think like key to that future is reusability. So that's why we've worked quite hard on reusability. Unfortunately, we haven't succeeded yet. And in fact, the last launch, ironically, was we actually had the best chance of landing the vehicle on the sort of drone ship that's keeping station in the Atlantic. So we were actually quite sort of geared up for hopefully this would be a really great launch, and unfortunately ended up being the opposite. Well, on my birthday, of all things. It was a real downer.
You'll remember it though, probably.
Yeah, it's definitely low point. But I do think in the future launches that we've got a decent chance of landing on the ship and then bringing the boost stage back to land. And then the next challenge, of course, is trying to figure out how to efficiently and effectively reuse it. And it is designed for easy reuse in theory, but we've got to see what the stage looks like when it comes back in one piece. Mm-hmm. We have been able to, over the last few years, do a number of vertical takeoff and landing tests of hardware that's essentially in the flight configuration. So we know we can handle the terminal phase. If things go right, we can take off and land, no problem. So it's just a question of completing all the pieces, and hopefully later this year we'll be able to do that. But that's key. So, but of course that doesn't address upper stage reuse, but it addresses boost stage reuse, which is sort of 70% to 80% of the cost. But I think would be a great step towards lowering the cost of space transport.
So, if you look at your history, I guess Zip2, PayPal, these are largely software type efforts. Now you've got Tesla electric cars, you're building a battery plant, a solar city. I guess you're involved in solar city. So why space? This seems, space to me, and just what I agree with you, seems to be more of a passion, and the others are businesses. But I can't tell. Why space? Why do you think it's important for us to have quick access to low Earth orbit?
Well, actually, technically, with Tesla and Solar City, they're about helping to solve the sustainable energy problem. Mm. So we're trying to make progress on that front with those companies. With SpaceX, it's trying to help solve the kind of spacefaring problem. I think that a future where we're a spacefaring civilization and a multi-planet species is a very exciting, inspiring, awesome future. Mm-hmm. And in order for that to happen, we've got to dramatically improve the cost of spaceflight. And that's why SpaceX exists, is to try to lower the cost of spaceflight, which we've made some progress in doing, but still I would call out improvements thus far evolutionary, not revolutionary. But with a lot of continued work, I think there's the potential for order of magnitude or greater improvements. Reusability being key to all of that, of course. And then hopefully, if we can keep improving the cost of space flight, then eventually, if that trend is in the right direction, it could be leading to a city on Mars, and certainly along the way, a lot of activity in low Earth orbit and the moon, and lots of other exciting things.
So one of the things we're trying to do with the International Space Station is try to figure out which industries will prosper from the use of low Earth orbit, to try to understand or help grow an economy essentially in low Earth orbit. And folks who are doing that are all taking risks today. Our job is to try to reduce the risk as much as we can near term, so that they can get the information they need to really have a business case for the future. But everyone's trying to calculate a risk. So is there an Elon Musk philosophy of risk versus benefit, and when you think is the right time to jump in? I mean, what is your thought on how to approach new industries, innovative areas, and when's the right time to jump in or not? Or do you just, is there no crystal ball, or is it a crystal ball or a Ouija board? I mean, how do you figure out what you should go after?
Well, definitely the Ouija board, of course. Much more reliable than the crystal ball. I mean, I don't really like risk for risk's sake or anything. And I do think that a lot of things are very risky with a low chance of success. But if you want to try to come up with an innovative breakthrough, that's going to be how it is. Anything which is significantly innovative is going to come with a significant risk of failure. But if you've got to take big chances in order for the potential for a big positive outcome. If the outcome is exciting enough, then taking a big risk is worthwhile.
Yeah.
That's really how I approach it. But then once executing down a path, I actually do my absolute best to reduce risk, or to improve another way of saying it, to improve the probability of success. Because when you try to do something that is very, very risky, that you have to spend a lot of effort trying to reduce that risk as you embark down that path. I mean, when I started SpaceX, I thought the odds of success were very low. I thought we'd most likely fail, but I thought, well, we should give it a try nonetheless. And then I'm not sure if you know what preceded SpaceX, because or why I got into the space.
Well, I remember you trying to purchase a vehicle too from our Russian colleagues.
Yeah, that's right.
What you're talking about? Yeah.
Well, actually, it was the reason I got into space was to try to increase NASA's budget.
Well, God bless you then.
So I'll tell you, so the roundabout way I thought that might be accomplished was, I thought, well, if NASA's budget was larger, then we could do more in space exploration. And I thought, well, particularly if we could get the public excited about sending people to Mars. And I thought, well, if I could do a small greenhouse and send that to the surface of Mars with seeds in nutrient gel, and you hydrate the gel on landing, you have a little miniature greenhouse, and then you'd have, the public tends to get excited about precedents and superlatives, so it would be like the, sort of first life on Mars, the furthest life's ever traveled, and you get people sort of excited about, well, but maybe we should send people there, like, the hell with plants, we should send people,
Right.
And then I thought, well, if that could get the public really excited about sending people to Mars, then that would translate into congressional support for a bigger NASA budget. That was the goal. And then I didn't have enough money to buy, and I thought that outcome would have a 100% chance of no commercial success. So the 100% chance of losing all the money. So compared to that, SpaceX, which I thought maybe had a 10% chance of success, that was an improvement.
There you go. Well, that makes good sense. So are you still thinking about that? I do remember that conversation. This was the idea where you use Martian regolith, you send these self-contained habitats, not habitats,
well, it's like,
but
it would only
plant
be
chamber
pretty
kind of things, and grow.
Small, yeah, like a meter across or something.
But just to prove the concept.
Yeah, just to get, I mean, the real goal was to get the public excited. You get some engineering data about what does it take to maintain a little habitat on Mars type of thing. But the main thing would be to get the public excited and, get people to be the public to be in favor of a bigger NASA budget. That was the goal.
Well, again, God bless you. That's a worthy goal. I hope you don't stop. So Commercial crew. So you've been selected as one of the providers for the commercial crew. Can you tell us a little bit about where that's headed for you as a company, and perhaps maybe how it's affected your company, if it has, if it's changed anything in how you approach space?
I think things seem to be going fairly well on the commercial crew front. I mean, overall, like there are small disagreements here and there, but overall, I think we very much agree with the way it's being done, yeah, I think it's pretty good. I mean, there are a few things where, it seems like the amount of sort of mass and volume reserved for poop is too high. Sorry, I don't know if that's but that's, there's like little things like that. We're like, well, are they really going to do that much poop? But it's quite a large volume. It really is. But they're pretty small disagreements. So I think that it seems to be pretty sensible. And then we did the launch abort test earlier this year, which at the Cape, which actually went pretty well. Yeah, so things are going along, getting pretty exciting. Yeah, I think there's also some potential use for Dragon 2 as a science delivery platform. Going to sort of delivering payloads to Mars or other places. We're in discussion with other parts of NASA about some of those ideas, because the propulsive landing, it could really lower the cost of getting science instruments to various places in the solar system. So that's kind of exciting.
So I'm going to come back to that in just a second. But commercial, the crew vehicle versus the Dragon cargo vehicle, clearly there are some significant differences. Yeah. Fairly innovative approach, I think, to abort testing, where traditionally you've seen the jettison rocket on top. It's a puller versus the pusher technique, where you utilize fuel that you otherwise would use for the on orbit, but of course you're not going there. So very innovative approach. Are there other areas where you feel like you're, from an innovation standpoint, you're making some significant strides with the crew vehicle?
Yeah, I think the big items the biggest item really for Dragon 2 is the ability to do a propulsive landing, and it's basically having heavy thrusters on board. So those same heavy thrusters can then do the abort but retain the engines. So instead of in a normal sort of crewed mission, like say take the Soyuz for example, they'd have a tractor motor on the nose of the vehicle that would have to be, basically a rocket engine on the nose that would have to be discarded on every flight, which is a potential reliability issue, and then you have obviously unable to reuse the abort system, and and it adds bunch of mass. But then in addition, those same thrusters can be used for propulsive landing. So you can achieve a precise propulsive landing, which on land or water, which is I think a significant improvement. I mean, it's sort of also it's sort of like it really I think feels more like the future to have that capability. And then as I mentioned, it can be extended to do payload delivery to the moon or Mars or other places, because of the generalized capability of propulsive landing to land almost anywhere.
Very good. So let's go back to Dragon. At one point you had a conversation, talked a little bit about something I think was referred to as Dragon Lab, where you go to low Earth orbit and do what I assumed was sortie kind of research and bring the vehicle back. Are you still pursuing that or something like that? Is this an area where you think that there is potential?
I think that there is some potential to essentially just take things to low Earth orbit and then bring them back, after a few weeks or something like that. It's not a huge area of attention at SpaceX, but I think we might do a few missions like that. Yeah, I mean, Dragon is very much sort of its primary optimization is as a transport vehicle to and from the space station. And so things like Dragon Lab and then the science delivery platform, I think, are interesting extensions of that. And I think as Dragon 2 first flies and then gets into regular flight, I think there probably will be some more applications that people can think of, particularly since with Dragon 2, the reusability of the vehicle should be quite high. So if we have reusability of the Dragon spacecraft and reusability of the booster, and somebody's willing to sort of do a bunch of flights with the fully reused system, there's the potential for much lower cost access to space. There is a bit of a chicken and egg challenge because there's a certain amount of fixed costs that have to be carried no matter what. So the marginal cost of launch, or the cost of each subsequent launch, can drop quite significantly as long as the launch rate per year is high.
It stays up.
Yeah.
Of course, that adds other challenges to the system.
Yeah.
Trying to fly as often as you need to make that.
Yep.
Well, let's see. I don't want to bore everybody with all my questions, and we had talked about if folks had any questions in the audience. Let's see this. Oh wow, they're not bashful. That's good. So I don't know if we're going to need microphones, but I'll start here.
So Elon, I came from Italy, from Milan, just for your speech here. And I would like to ask you a question, which is not, I'm coming from the solar energy business, actually. So, but my question is different because you are like a kind of mentor and a visionary, and you give hope to a lot of people around the globe, because when they see you, they realize that they can realize their dreams. But my question is different. When you are a dreamer, when you are a visionary, of course you have your vision, but there are moments that sometimes maybe you stop believing in this vision, especially in the moments of some problems or failure. So could you tell me, and could you tell also to thousands of people who maybe will be motivated by your answer, what keeps you fighting for your vision? What helps you to reach your dream?
Well, I mean, I think I'm kind of constitutionally just geared to just keep going. I don't know. It's yeah. I mean, it just I don't know. I mean, it certainly there are times when things don't go well, and then that's quite dispiriting for sure. And so then it's difficult to proceed with the same level of enthusiasm. But I do think the things that we're doing are pretty important to the future. And if we don't succeed, then it's not clear what other things would succeed. And if we don't succeed, then we will be certainly pointed to as a reason why people shouldn't even try for these things. So I think it's important that we do whatever is necessary to keep going.
Okay, and last question. Elon. So in 2004, when you are going to Burning Man with your cousin, you were thinking, there is a sun, and let's make energy out of it.
Yeah.
And I would like to ask you, why do you believe so in solar energy and in clean tech energies and also in sustainable energy? And the last question, I will not ask any more questions. What will be the role of solar in the exploration of Mars?
Sure. I think solar energy is probably fairly significant for Mars. And what's going to be quite important is having a very lightweight solar system that both volumetrically and gravimetrically dense. So actually, you were sort of playing with different concepts, like that party thing where you inflate it and it rolls out, the thing. Like one of the solar concepts is to have like a big roll that you just basically inflate and it rolls out with like really thin solar panels on it. But it's going to be pretty important because really you either got to do that or nuclear. Nuclear has its challenges, but for solar it's pretty straightforward. So I think solar is very important to the future exploration of Mars for sure.
So thank you, and I wish you that your next birthday is very successful.
Thanks.
Thank you so much.
Okay, let's go. Oh, okay, go ahead, Valentin.
My name is Valentin Uvarov. I am from the United Rocket and Space Corporation, which shortly will become a part of state corporation Roscosmos. So I made this long quest to the west because I'd like to ask one question of Elon Musk. What is his secret to become a successful businessman in the space industry? And then coming back to Russia to tell Russian businessmen there is a way to become a tycoon in the space industry. So, seriously speaking, I'd like to ask you, when you started your business, was the government your partner? Was it useful? In what areas? And so there are always two sides of the coin.
Sure.
There were times when you had to fight bureaucracy. Thank you.
Sure. Well, I should say with respect to starting a space business, it's definitely not the easiest environment to start a business. I think if most people were to rank order what's the highest return on investment, I mean, space would not be very good. I'm very pro-space, so it's like, but it's, it's just true that like if you, start a hedge fund or if you're in like many other industries, then it's much easier to make money than the space industry. This is not the easiest one to make money in. Car industry also quite difficult. In fact, when starting SpaceX, the joke, I heard the joke, this joke so often, it was ridiculous. The joke was, how do you make a small fortune in the space industry? The punchline, of course, being start with a large one. I got to a point, I'd heard the joke so many times that I would just get to the punchline and say like, well, I wanted to figure out how to turn a large fortune into a small one. That was my goal. And they're like, wow, how did he know that? I do think there is opportunity in space, but it's tough going. I think if SpaceX and other companies can lower the cost of transport to orbit and perhaps beyond, then there's a lot of potential for entrepreneurship at the destination. You can think of it like the Union Pacific Railway. Before there was the Union Pacific Railway, it was real hard to have commerce between the West Coast and the East Coast. It would go by wagon or a really long sailing journey. But once there was the transport, then there were huge opportunities. And now look at sort of, the California and Washington State and all the industries that have been created in Silicon Valley and Hollywood. But you got to have that fundamental transport element. Otherwise, it's really tricky. So we're trying to establish that transport element, make it easier to get to low Earth orbit, and hopefully in the future make it easier to get to the moon or Mars. I do have sort of this long-term vision of like, if there was affordable transport to a place like Mars, I think the entrepreneurial opportunities would be phenomenal, because there'd be people that would want to create everything from the first pizza joint to the first iron ore factory to be like just an enormous amount of opportunity for people to create things on Mars, and then there'd be different things on Mars. Some of the things on Mars would be different that we don't even imagine on Earth. It'd be very exciting. So I think that's really key to making things happen in space. Is you've got to have some place to go and some way to get there.
So along those lines, you read Andy Ware's book, The Martian?
Yeah, it was good.
What did you think?
I thought it was pretty excellent. Certainly one of the most realistic books on Mars that I've read. I mean, like there were a few things, like the wind force on Mars is not really that high.
Well, there's
It's not going to knock you over or anything. It's obviously high velocity, but low force. But overall, I thought it was pretty cool. And apparently it's been made into a movie and everything.
Yeah.
So
you don't have a cameo on that one too?
I don't have a cameo on that one.
All right.
I'm a little worried that it might not make people too keen on going to Mars. It's like, looks really hard. I think we need a show about how Mars is awesome, and it's like the Wild West, and you got the gunslingers and like the cool cowboys and that kind of thing.
All right, maybe you got to write a book too. Let's see, there's a question over here. Go ahead.
Hi there. My name is Anita Goel. I'm here out of Harvard and MIT, run a company called NanoBioSim. So in your vision and dream to achieve low-cost space travel, how do you allocate your investments between engineering and essentially driving down the cost of existing technology versus investing in new breakthrough physics? Things like breakthrough propulsion physics, anti-gravity. What's your vision in the bifurcation of those two kinds of portfolios?
Well, we don't spend a ton of time on new physics. I think with current physics, there's huge potential. So rather than rely on a breakthrough, which really it's difficult to envision what that breakthrough would exactly be. Or even inexactly be. I'm quite confident that with what we know of current physics, sort of just going with the kind of where the standard model of physics is today, that there are dramatic improvements possible in space flight. And I think with certainly with Falcon 9, I think we can make improvements. And then with our next generation rocket system, which is still many years away, that'll be a deep cryo methalox system. I think we can achieve full reusability, and that's a huge potential for like maybe a 2 order of magnitude reduction in the cost of spaceflight. As far as R&D is concerned, like we hire great engineers as fast as we can find them. So it's like it's not that easy to find, or I should say great engineers with the sort of like the right mindset and everything. We hire at the maximum rate that we can find people that we think would really be an asset to the team. So there's no limitation on that.
Okay, over here.
Hi, my name is Zachary Maltz. I'm a student from Babson College. I just want to say it's an honor to be here. I read Ashley Vance's biography about you, and one thing that really was intriguing to me was the Super Draco engine for the Dragon V2 that was printed out of 3D technology. Do you envision using that technology more in the future and when you first space exploration? And do you think how will that affect the costs in terms of getting to Mars, everything like that?
Yeah, absolutely. So as you alluded to, we actually print the Super Draco engines. So they're printed out of titanium Inconel, and that actually allows us to reduce the cost of those engines quite a bit. In particular, because we can print integral cooling channels. So when you've got an hourglass chamber and you've got cooling channels in the wall of the chamber, where the whole wall consists of cooling channels, it's normally quite difficult to create that thrust chamber and nozzle, because you've got to create an inner jacket, outer jacket, kind of machine the inner jacket, and then braze the whole thing together. It's a real pain. And you've got a bunch of joints in there to make it all work. So with printing, you can print something that you can't make by any other means. So it actually ends up being lighter and cheaper than if we built it by traditional methods. For our next generation engine, which we call the Raptor, which as I mentioned is sort of it's a deep cryomethalox. So what I mean by that is the methane and oxygen are cooled to close to their freezing point, so not far from their freezing point, as opposed to close to their boiling point. which is normally the case. For that engine, we're trying to print as much as possible. It's a bit, the biggest limitation on 3D printing right now is the size envelope. So there's a limit on how big we can print something. But we're able to print the turbopump components and much of the injector, not the whole thing, but many of the critical parts we can print. So that actually helps us in speeding up the development. So instead of waiting for castings to be developed, which can take several months, and then if the casting is wrong, you've got to iterate on the casting, and each iteration can take several months. With printing, those iterations can be reduced to a matter of weeks or months. So that actually helps with the speed of development as well.
Let's see. Over here.
Hi, I'm Ross Bunchrock with a company called High Orbit. I wondered if you could give us a little bit of an update on what's going on with the Hyperloop, and is there any overlap between the work you're doing with SpaceX and Hyperloop technology?
Yeah, SpaceX is not, neither I nor SpaceX are doing anything to try to commercialize the Hyperloop. There are, I think, at least two, maybe more than two companies that have formed that are completely independent of me or SpaceX that are working towards commercializing the Hyperloop technology or the Hyperloop idea or design. What SpaceX is doing is we're going to just create a little student competition for Hyperloop ideas. So kind of like around the way that Formula SAE works, where students can come up with a design and compete against each other to design the best pod. So what SpaceX will do is just construct about a mile-long low-pressure tube, nearly vacuum tube, basically, in which students can kind of race their pods. So it's just basically to support, get students excited about engineering. That's the only involvement of SpaceX and myself with the Hyperloop at this point.
Okay, over here.
Hello, I'm Paola Castagno. I'm a sociologist, and I'm writing a book about the International Space Station. How would you describe the scientific value of the International Space Station? And where would you draw the line between luxury and need when it comes to space exploration?
Well, I mean, for space, I really spend all of my time thinking about just how to get to the space station. To be honest, I actually hadn't even really seen a proper movie of the inside of the space station until I went to see a preview of the new IMAX thing that's coming out, and it's amazing. Like when that space station IMAX movie comes out, people are going to get blown away. It's awesome. I actually brought my whole team at SpaceX to go see the preview of the IMAX movie, I mean, it is a very unique laboratory because it's the only thing that's in sort of microgravity, that's above the Earth's atmosphere, and you can learn a lot about basically human physiology and do experiments that you can't really do in any other lab. And you can bring scientists up, and they can actually work in this incredibly unique lab. So I think that there's a lot to be gained there, and I think you can't sort of ignore the coolness factor of it. Like people think it's pretty cool, so I think it's pretty cool, and the public want to have something going on in space. That involves people and and it's just I don't know, it's the coolest thing going on in space. So there's a lot of value to that.
We try to sell's the wrong word. It's the word we use, but sell's really the wrong word. We're trying to get people to recognize that there's a platform in low Earth orbit and that this is important. What's done in low Earth orbit has benefit to those of us on Earth that will never actually go to space. But in doing that, you're trying to get their interest level, and part of their interest level is the cool factor that you talked about. And I've always kind of struggled with that, being sort of a black and white. I understand the purpose in my head. That's why I joined NASA, right? But over the years, this is one of the things that I've started to recognize as important. So my question to you is, I've heard a rumor that for the suits for commercial crew that you wanted to play a role in that. And so is that true? And is there some reason behind the design of the suit that you want to personally be involved in other than crew safety?
Yeah, I think we've actually spent a lot of effort on the spacesuit design, on both the functionality and the aesthetics. But I think just getting, it's actually really hard, because if you just sort of optimize for functionality, it's one thing. If you optimize for aesthetics, it doesn't work. Like, those things that you see in movies, they don't work. So it's like, okay, how do we make something that looks cool and works? With a key goal here of being that, when people see that spacesuit, we want them to think, yeah, I want to wear that thing one day. That looks awesome.
Yeah. That's good.
So that's the reason for it.
Very good. Let's see. We'll do a couple more questions, and then can we get back in the back here, or do we have somebody else here already with the microphone? All right, go ahead. Thank you. And we'll do one more after that. Okay.
I'm Alex Perlman. I'm with Boston Magazine, and I'm writing for Vice today. I was hoping that you could give us a little bit of an update on the most recent news with the idea of putting satellites to provide internet to developing countries and unconnected people. Thanks.
Sure. So we're still at the early stages of sort of a big LEO constellation communication idea. And we're hopefully going to launch a test satellite next year. But I think the long-term potential of it is pretty great. But I don't want to overplay or overstate things quite this or any stage of the game really. But the long-term goal is to create a comprehensive global communication system that provides high bandwidth, low latency connectivity anywhere in the world, and provides cross-links through the satellites so that you can have improved long-distance internet. Because one of the things that sort of you realize when you look at this is that you can actually have a more direct path through space, and photons move faster. I mean, depending upon what fiber optic material they're running through, photons actually move about 40 to 50% faster in vacuum than they do in fiber optic cables. And if you look at the way that the fiber optic cables go, they trace the outlines of the continents, and they go through many repeaters and routers and everything. So if you want to, say, communicate from a server in California to one in South Africa, it's a very, very long route and sort of very roundabout path. And it's high latency, low photonic speed. And you could actually have that communication be quite a bit faster if it's in space. So I think there's the potential for doing a fair bit of long-distance internet activity, as well as providing bandwidth broadly. But it's also worth saying that a lot of companies have tried this and kind of broken their pick on it. And I think we want to be really careful about how we deliver it, about trying to make this thing work, and not overextend ourselves. So we're being fairly careful about it, but I do think this is something that should be built and would be quite good to have.
What are you looking to do differently than others have done previously?
Well, in our case, the communications technology would be substantially more advanced. So in the past, with, say, attempts like teledesic, the electronics of the day were very low bandwidth. I mean, really analog or barely digital. and they weren't very high bandwidth. So it really didn't compete with, say, with terrestrial phones. In the case of Teledesic, they were looking to compete with or to address cellular needs. The system we're talking about would not attempt to compete with cellular needs. So for example, it wouldn't compete directly with, say, Iridium, which can talk directly to a handset. Our system would seek to talk to a small user terminal that's about the size of a pizza box, or much like current dishes that are the satellite dishes, but it will be flat because we have phased array antenna that's tracking the satellites. But you could mount it in a window or just anywhere outside. As long as it can see the sky, it would work.
See, back here, we'll take our last question back here.
Hey, Elon, thanks for coming out. I would like to show you, we brought a virtual reality camera here to record for the first time. We have a small startup in San Francisco called Space VR, and we believe that virtual reality is the future of space exploration because you can put people on the very front of every exploration mission. Is that something that you've given much thought or have any opinions on?
Well, I've received the virtual reality demos at Oculus and at Valve, and it's pretty impressive. You can sort of imagine if that's extrapolated into the future, it's really going to super feel like you're there. And I wonder if some people are never going to want to take that off, honestly. It's pretty, it's pretty entrancing. But I do think it'd be quite exciting to do that for space as well, yeah. Do you have a setup here? Yeah, it's right here. Okay, it's right there, wow, okay.
Yeah.
Cool.
If you have time, we have SpaceX launched the last one, so if you want to come by the booth, you can see it in VR.
Okay. Where are you based in? Where are you based?
In Howard, San Francisco.
Okay. I think maybe today is going to be tricky, but but maybe since you're based in California, we could arrange something in the coming weeks. All right.
Well, let's see, Elon. We'll call it a conference. I wanted to first thank you very much. You've been very generous with your time, and we, from the moment I called you, you were all in, and it's really this open conversation and your thoughts on what's in front of us that really excites us all in this room. So thank you very much for your time. We really appreciate it.
Yeah, thank you. Thanks for having me. All right.
All right. Thanks, man. Appreciate it. See you soon.